Okay, so in the last class we discussed methods of expressing concentrations, under which we discussed percentage mass by mass of way of expressing concentration, percentage mass by mass. Then we also discussed percentage mass by volume. Then we discussed percentage volume by volume. Okay, then after that we discussed mole fraction, expressing concentrations of solutions, mole fraction we discussed. Then we also discussed what is called molarity. Okay, what we are going to do in this class is we are going to discuss the other concentration terms. Okay, like the next important concentration term is actually molality. So we will discuss molality today. Molality and other concentration terms. Let me write here. So the next one is molality. We express this with a symbol small m. Okay, molality. What is molality? Molality of a solution, or molality of a solution is nothing but, okay, molality is number of moles of solute, present in 1 kilogram of solvent. 1 kilogram of solvent. See here, you have to note few things. Molality is nothing but number of moles of solute. Okay, you must express solute in terms of moles. Then you should take solvent, not solution. Okay, in the see in all these, right, in all these concentration terms, if you see here, in all these four, I have told you we took only solutions. Okay, number of moles of solute in solute, like that. We never considered solvent here, but the first time I'm introducing what is called solvent. Okay, so in molality, solute should be in number of moles and solvent should be in kilogram. That's the point. Okay, we are not considering solution here. It is the number of moles of solute present in 1 kilogram of solvent. Okay, so we can also write this hello students, am I audible? Hello?
Yes, sir.
Yeah, right. Okay. So molality is the number of moles of solute present in 1 kilogram of solvent. Okay. Mathematically, you can also express like this. Molality m is equal to number of moles of solute N2 divided by mass of solvent. Okay, number 1 represents solvent, I told you in the last class. So W1 means mass of solvent. It should be in kilogram. mass of solvent should be in kilogram. Okay, so molality is nothing but N2 by W1. But usually we put weight in grams. Okay, usually we give weight in grams. So if weight is given in gram, you should convert that into kilogram. Okay, therefore molality is equal to number of moles divided by weight. If weight is given in gram, you have to divide that value by 1000, so that you will get in kilogram. Bring it to the numerator, so I can write molality equal to 1000 into number of moles of solute by mass of solvent. Now solvent is in grams. Okay, this is the formula we use to calculate molality of a solution. Molality is nothing but number of moles of solute present in W1 gram of solvent. Okay, remember 1 represents solvent. Last class I told you. In solution chemistry, this is the convention we follow. 1 means solvent and number 2 represents solute. Okay, so N2 means number of moles of solute. W1 means mass of solvent in gram here. Okay, in gram. Right? So this is the definition for molality. And remember, in molality we are taking number of moles of solute and we are taking mass of solvent, not volume of solvent. Since there is no volume term, okay, molality M is temperature independent. Temperature independent. If temperature changes, molality does not change. That's the point. Okay. Molality is temperature independent term, concentration term. And what is the unit? What is the unit of molality? Remember, unit of molarity, in the last class I told you, unit of molarity is mole, right? Mole per liter or per decimeter cube. Mole per liter or mole per decimeter cube is the unit of molarity. Unit of molality is mole, right? Mole per kg. Mole per kg, because here we are using mass of solvent. Okay, therefore the unit should be mole per kg. So remember, this is the unit for molarity and this is the unit for molality. Is this clear, student? Any doubt? Any doubt in this?
No, sir.
Yeah, take turn. Yes. Now, so you know very well, under molarity I have told you, in molarity, that is capital M, I have told you molarity is nothing but number of moles of solute. Okay, molarity is nothing but number of moles of solute present in 1 liter of a solution. Okay, present in 1 liter of a solution. This is the definition for molarity. I have told you already. Here we should take solution. Now what I am going to do, I am going to give the relation between molarity and molality. Okay, so what is the relation? Relation between, right, molarity and molality. This is very useful for any if you write any competitive examination. Okay, then these relations are very useful. Okay, what is the relation between molarity and molality? Yes. Yeah. Here, you know very well, for molarity you require solution, whereas for molality you require solvent. Okay, and solvent should be in kilogram. Here molarity, volume should be in liters. So if you want to convert molarity into molality, then you should convert the volume into mass. Okay, so what what I'll do is that, let me write like this. So see, molarity means number of moles of solute present in 1 liter of solution, right? Now let me write like this. Say N2 moles of solute, N2 moles of solute, okay, present in V liter of solution, which gives a molarity M, right? Now I am giving N2 moles of solute present in V liter of solution, that gives you molarity. So what is molarity? Molarity is nothing but number of moles of solute divided by volume of the solution in liter, that we know, right? Now what I am going to do, let me convert the volume into kilogram. How to do that? You know the relation between volume and mass. Mass is equal to volume into density, correct? Students, am I right this? Am I right? Mass is equal to volume into density, is it correct?
Yes, sir.
Right? So now we have volume here. So if I multiply volume into density, I will get what is called mass, right? So if you want to convert this volume in liter into density or mass, what you have to do, you just multiply this by density. So I can also write this as N2 moles of solute, N2 moles of solute PRE present in, okay, volume of the solution into density, right? Volume into density. Volume should be in ml, right? See here, volume is in liter. First we will convert volume into ml. So what you have to do, you multiply this by 1000. Okay, so let me write here 1000 into V. You will get volume in ml into density. Density should be in gram per ml. Density is gram per ml. Okay, volume should be in ml now, because I have converted the volume liter into ml. Okay, so 1000 into volume into density, right? This will give you the total weight of the solution, right? Solution. So the N2 moles, see, I'm just writing the same thing. What I did, I just converted this volume into mass. Okay, now this much gram of solution contains N2 moles of solute, right? So let me write in the next page so that we can use direct formula, but you must know how the direct formulas are coming. Okay, so the point is this. Now listen, 1000 into volume into density, right? This much grams of solute, or I'm sorry, solution contains N2 moles of solute. I have written in the other way, that's all. Okay, students, is this clear? Any doubt? Yeah.
No, sir.
Yeah. Now you know very well, this is actually solution, mass of solution, right? What is the mass of solvent, right? Solution is nothing but solvent plus solute, right? Mass of solution is nothing but mass of the solvent plus mass of the solute. So if I subtract mass of the solute, see, this is total mass, right? Solution means total mass. From the total mass, if I subtract mass of the solute, I will get mass of solvent. Okay, so 1000 into volume into density. From this, if I subtract mass of the solute. How to find the mass of the solute? I know the number of moles. Okay, N2 moles of solute is present. So number of moles into molar mass of solute. Molar mass of solute, I'll write just M2. Students, observe this carefully. Number of moles into molar mass will give you mass. So this is mass of solute. Okay, and this one is mass of solution. So if I subtract this, I will get what is called mass of solvent. So this is equal to mass of solvent. Mass of solvent. Okay, so now listen. So 1000 into V into density minus N2 into M2. Okay, this much grams of solvent. Students, observe carefully. This much grams of solvent contains N2 moles of solute. Okay, I have just converted solution into solvent now. I subtracted the mass of solute from the mass of solution, so you will get mass of solvent. So this much grams of solvent contains N2 moles of solute. Okay, therefore what is molality? Molality is nothing but, okay, number of moles of solute divided by volume of the solvent in kilogram. So this is 1000 into volume into density minus N2 into M2. This is mass in gram. You have to divide this by 1000 so that you will get the mass in kilogram. Students, listen, this is mass in gram, right? But what is the definition for molality? Molality is nothing but number of moles by volume of the solvent in kilogram. So to convert gram into kilogram, I am dividing this by 1000. Bring the 1000 to the numerator. So you will get the final expression, which appears like 1000 into number of moles divided by 1000 into volume into density minus N2 into M2. Okay, so this is the way of expressing what is called molality. Okay, so if molarity is given, students, if molarity is given, see the number of moles and see the volume. Okay, here volume should be in ml. From the molarity, you find out number of moles and the volume in ml. You can easily calculate the molality. Right? Students, is this clear? Any doubt?
No, sir.
Yeah, take two. You can also write in the other way. Just take down this. I'll give another way of comparing, because you can directly put molarity here. You can directly put molarity here. This is one way of writing the answer, but here to find molality, I am taking number of moles of solute and I am taking volume of the, this is volume of the solution, right? This is volume of the solution, but it should be in ml. Okay, so if you know these values, you can calculate molality. These values N2 and V can be obtained from molarity, right? Or otherwise you can also write in this manner. Just I'll tell you, listen, just I'll tell you like this. M, what is molarity? M means molarity, you know, right? You can also write like this. This is a simple way of writing. Molarity, what is molarity? Molarity means, okay, M moles of solute. Okay, if molarity is M, which means M moles of solute. Students, observe this carefully. If molarity is M, which means M moles of solute present in 1 liter of solution. 1 liter of solution. You can write like this also. Okay. Now to convert volume into mass, what you have to do? Multiply this by density, right? So 1 liter means volume is 1 liter, so I'll multiply this by 1000. So 1000 ml of solution. I'm just converting liter into ml. So 1 liter is nothing but 1000 ml. 1000 ml into density. 1000 into density should be in gram per ml. Okay, so 1000 into density will give you mass of the solution. 1000 into D, okay, this much mass of solution, this much grams of solution, contains m moles of solute. Okay, this much grams of solution contain m moles of solute. This is mass of solution, but for molality we want mass of solvent. So what to do? From this you subtract the mass of solute. So 1000 into density, student, 1000 into density minus, what is the mass of solute? Very simple, number of moles, m is the number of mole here, into molar mass of solute. Number of moles into molar mass of solute will give you mass of solute. If you subtract mass of solute from the mass of solution, I will get mass of what is called solvent. So this much grams. This much grams of solvent contains m moles of solute. Okay, m moles of solute. Now we have solvent, we have solute moles, number of moles of solute. Therefore, you can define molality as, so therefore, what is molality? Molality is nothing but number of moles, which is m, divided by mass of solvent. But now mass of solvent in gram. To convert a gram into kilogram, you have to divide this value by 1000. So mass of the solvent, 1000 into density minus molarity into molality, so molecular weight, divided by 1000. That 1000 will go to the numerator. Yes, student, listen carefully. This is direct relation where I am relating molality with molarity. Note down. I have given you the direct relation. So if you want to convert molarity into molality or molality into molarity, remember you require density of the solution. Here density should be in gram per ml. This is density of solution. D here is density of solution. What is m, students? What is m here? What is m here? See, what is m? Capital M.
Molarity.
Yes, capital M is molarity. What is this M2? M2 is molar mass of solute. Note down. M2 is molar mass. So if you know the solute, you can find out what is the molar mass. Okay, so this will give you the relation between molality and molarity. Okay, you can use this or you can use this relation, right? Sometimes they'll give molarity. If molarity is given directly, you can use this one. Sometimes instead of giving molarity, they'll say that N2 moles of solute present in some volume of solution. Okay, if that information is given, you can calculate molality using this. But listen, student, this is the basic point you should keep in mind. If you want to convert molarity into molality or molality into molarity, in both these conversion, you require density of solution. Okay, you require density of solution. Keep that in mind. Okay, students, is this clear? Any doubt? Any doubt here?
No, sir.
Okay, ma. Good. Take down. Now, so this is the definition for molality and how molality is related with the molarity we discussed. Now what I'm going to do, I'll introduce the next term, that is normality. Student, this is not in your syllabus anyway, which is very useful for competitive examination. Okay, what is meant by normality of a solution? This is another way of expressing concentration, which is useful for your competitive examination. So I'm just going to give you the definition and some important relations. What is normality? Normality is defined as, normality of a solution is defined as number of equivalents or gram equivalents. Number of gram equivalents. Students, observe this carefully. Normality is number of gram equivalents of solute present in 1 liter of a solution. 1 liter of a solution. Okay, number of gram equivalents of solute present in 1 liter of a solution. This is the definition for normality. Okay, mathematically you can write normality equal to number of gram equivalents, or you can even write simply equivalents, number of gram equivalents divided by of solute, number of gram equivalents of solute divided by volume of the solution in liter. Okay, volume of the solution in liter. Now, what is meant by number of gram equivalents? How to calculate? Very simple. If you want to calculate number of gram equivalents of solute, just take the mass of solute, W2 means mass of solute, divide this by equivalent mass. Equivalent mass of solute. Mass by equivalent mass will give you what is called number of gram equivalents. Students, observe carefully. Mass by equivalent mass will give you number of gram equivalents. So W2 by E2 will give you number of equivalents into volume of the solution in liter. Okay, right? So this is a very useful one. Keep this in mind. From this you can also write W2 is equal to bring all this term this side, normality into equivalent mass of solute into volume of the solution in liter. Okay, this will give you, this is a very useful expression. If you know the normality, equivalent mass and the volume, you can find out what is the mass of solute present in the solution. Okay, very useful relation. Keep this in mind. So this is normality. Here also, see, volume is involving, right? We have 1 liter. Liter means volume, right? So volume is there. Therefore, listen, volume depends on temperature. Therefore, if temperature changes, volume will change. If volume changes, concentration will change. So normality is temperature dependent concentration. Temperature dependent, which means if the temperature changes, concentration will change. Okay, take two. So temperature dependent term. Now I'll give you one more important relation, that is the relation between normality and molarity. What is the relation between normality, right, and molarity? Relation between normality and molarity. Okay, yeah, this is very simple actually. You know very well, normality is nothing but mass of solute. Just now we wrote mass of solute divided by equivalent mass of solute into volume of the solution in liter. Okay, and you know very well molarity is nothing but mass by molar mass. Mass of solute by molar mass of solute will give you number of moles into volume of the solution in liters. Okay, this is the formula for molarity and this is the formula for normality. What's the only difference? Here I have equal mass, here I have molar mass. Okay, except these two, the other things are same, right? So what I'm going to do, I will give you one important term called n factor. Let me write simply NF. It is called n factor. What is n factor? Very simple. Molar mass by equivalent mass. Students, observe carefully. Molar mass by equivalent mass will give you what is called the n factor. Right? Molar mass by equivalent mass will give you n factor. Right? Take down. So what I'm going to do here in the place of or I can write E2 equivalent mass is equal to molar mass by n factor. Is it correct, students? Is this correct?
Yes, sir.
Yeah, this is n factor. N factor means it is just a number. N factor is nothing but molar mass by equivalent mass. Okay, so equivalent mass is equal to molar mass by n factor. Now I am going to replace this E2, okay, by this quantity. So I can write normality. Therefore normality is equal to, okay, W2 by, instead of E2 I'll put this M2 into n factor divided by n factor into volume of the solution in liters. Okay, this n factor I'll bring it to the numerator. So normality is equal to n factor into W2 by M2 into volume of the solution in liter. Yeah, student, tell me what is this quantity? What is this quantity? See this.
Molarity.
That is nothing but molarity. So I can write this as n factor into molarity simply. So normality is equal to n factor into molarity. Note down. Normality is equal to n factor into molarity. This is the relation between normality and molarity. If you know the n factor, right, you can say simply the relation between normality and molarity. Right? Take down. Okay. Yeah. This is the relation between normality and molarity. Okay. N factor is nothing but molar mass by equivalent mass. So if you know the equivalent mass of solute and molar mass of solute, okay, just divide molar mass by equivalent mass, you will get n factor, and using that n factor you can calculate what is called normality, or you can write the relation between normality and molarity. Okay, now, or you can say if NF is available and if normality is available for a solution, using these two you can calculate molarity. So if normality is available, you can calculate molarity. If molarity is available, you can calculate normality. Okay, provided you must know the n factor. Okay, yeah. You can find this n factor for acids and bases, salt, oxidizing agent, reducing agent in a different manner. Okay, let us not go into the detail, right? So I'll just stop here. Then we will discuss the next important concentration term, that is parts per million. Students, take down next important term, parts per million. We say that it is ppm, parts per million. We use this parts per million whenever the concentration is very, very low. Okay, whenever concentration is extremely low, okay, whenever concentration is extremely low, then we use the concentration term parts per million. Say for example, the dissolved oxygen in water. Okay, generally dissolved oxygen in water is very, very low. In order to express the concentration of oxygen in water, we use what is called ppm. Okay, ppm should be used whenever the concentration is very, very low. Okay, right. So what is meant by ppm? What is ppm? Simple. Parts per million. You can calculate using this formula. Parts per million is nothing but mass of solute in grams, okay, divided by mass of solution. Mass of solute in grams divided by mass of solution. This also should be in grams. Okay, mass of solute by mass of solution into 100, into 10 power 6. 10 power 6 will give you parts per million. Okay, so you require mass of solute, you require mass of solution. If you divide these two and multiply by 10 power 6, you'll get ppm. Okay, right. So by definition sake, we say like this. Definition sake, what is definition? Parts per million means it is the number of parts of solute present in 10 power 6 parts of solution. Number of parts of solute present in 10 power 6 or 1 million. 1 million part of what is called the solution. Okay. Yeah, students, take down this. This is very, very important. And you know very well, listen, I'll keep this quantity as such, numerator, denominator, all this quantity as such. I'll separate this into like this, 10 power 2 into 10 power 4. What is this term? Can you tell me? What is this term? We have seen this in the last class.
Mass
percent.
Very good, very good. So parts per million is nothing but percentage mass by mass, okay, into 10 power 4. You can also write like this. If percentage mass by mass is given for a solution, just multiply this into 10 power 4, you will get parts per million. Okay. Now, just I'll give one simple problem to understand. Okay. Yeah. First take down, students. Here, see, we are not using any volume term here. There is no volume. We have only mass. Therefore, parts per million, okay, is temperature independent. You must know which are all the concentration terms are temperature dependent and which are all the concentration terms are temperature independent. So this is temperature independent term. Now students will do some simple problems. Okay, then I'll give you I'll just tell you I'll give you some problems which are available in book, just that you try to do. Okay, and in the next class you just show me the problems. Okay, that is I'm going to give you only the in-text problems, right? You try to solve it. The chapter back problems will do, right, in the class. Okay, now I'll do some problems, some simple problems based on these concentration terms. So we have.
Sir, we don't have a textbook, so could you please send the questions in the group,
sure,
sir?
Sure. Yeah, will do. Yeah, I'll send it. Yes, ma'am. Right. Now, students, take down the problems. Problem number 1. Problem number 1. Okay. Let me ask like this: 500 gram of toothpaste, contains say 5 gram of fluoride. Okay, 500 gram of a toothpaste contains 5 gram of fluoride. Calculate fluoride concentration. Calculate fluoride concentration in ppm. This is the question. Calculate fluoride concentration in ppm. Students, fluoride is the solute here. Fluoride is the solute, and the toothpaste is your solution. Okay. So, how to calculate parts per million ppm? What's the formula for ppm, students?
Mass of solute by mass of solution.
That's all. Simple, right? So, mass of solute in grams divided by mass of solution, that should also be in grams, into 10 power 6, right? This is the formula. Now, mass of solute is available 5 gram divided by mass of solution 500 gram into 10 power 6. So, this is 1 5 5, this is 100. 100 means 10 power 2. So, 10 power 6 by 10 power 2 will give you 10 power 4. Is it clear, student?
Yes, sir.
So, fluoride concentration in the toothpaste is 10 power 4 ppm. 10 power 4 ppm of fluoride is present in the toothpaste. Very simple problem, easy to understand. Okay, then take down another problem. We'll do few problems now. Yeah. Now we'll do another problem. Problem number 2. Uh, 9.8 gram of sulfuric acid H2SO4 is present in 250 ml of an aqueous solution. 250 ml of an aqueous solution. 9.8 gram of sulfuric acid is present in 250 ml of an aqueous solution. Calculate the molarity of the solution. Calculate the molarity of the solution. Okay, we want molarity now. Molarity. Yes, how to do that? Students, how will you calculate molarity?
Number of moles of solute by volume of solution in liters.
Okay, yeah, you can use direct formula. Yes, you're right. Right? What is molarity? Molarity M. I'm just using the notations, but you should write fully. Okay, molarity M is equal to, right? We have direct formula I have given already. Molarity is nothing but mass of solute divided by molar mass of solute, okay, into volume of the solution in liters. Volume of the solution in liters. Okay, so now mass of solute is available 9.8 gram divided by molar mass of solute. For sulfuric acid, what is the molar mass of sulfuric acid, students? I told you to remember that. Molar mass of sulfuric acid. Yes, everyone turn on your camera.
98, sir.
98, very good. Molar mass of sulfuric acid is 98. What is the molar mass of glucose? Glucose?
$180, sir.
180, good. Molar mass of calcium carbonate?
100.
100, yes. Okay, remember those values, it's very important, right? 98 into volume of the solution in liter. Listen, here solution volume is given in ml. See this? It is in ml. You should convert ml into liter. How? Ml, divide this value by 1000. Okay, you will get volume in liter. To convert ml into liter, just divide the value by 1000. Okay, so this is nothing but 9.8. I'll bring the 1000 to the numerator, into 1000 divided by 98 into 250. So 250 4 times is 1000. 9.8 by 98 is 0.1. 0.1 into 4 is 0.4. Okay, so this is the molarity, and the unit is mole, this much mole per liter. So molarity of the solution is 0.4 moles per liter. Is this clear, students? Okay, take down.
Yes, sir.
Yes, sir.
Yeah, take down. Now we'll do a few more problems. Three. Okay, not X percent, I'll give like this. 5% mass by volume of aqueous sodium chloride solution, aqueous sodium chloride solution, right? 5% mass by volume of aqueous sodium chloride solution is given. What is the molarity of the solution? Find the molarity. Students, observe this carefully. I have given mass by volume solution. I am asking you to calculate the molarity of the solution. How to do that? Yeah. Okay, calculate molarity of, this is the question, calculate molarity of 5% mass by volume aqueous solution of sodium chloride. Okay, so here we need to find out molarity. So first I'll write the given data. What is this given data? 5% mass by volume means 100 ml of solution. Do you remember that, students? 100 ml, 5% mass by volume means 100 ml of, see the definition which we gave in the last lecture. Okay, 100 ml of solution contains 5 gram, 5% means 5 gram, 5 gram of sodium chloride. Is it correct?
Yes, sir.
Okay, that is the meaning for 5% m by v. 5% m by v means 100 ml of solution contain 5 gram of sodium chloride. Okay, now first I will convert, this is the mass of solute sodium chloride. Okay, first you convert this into number of moles. So 100 or I'll ask you one question. If 100 ml contain 5 gram, 1000 ml contains
50 grams.
50 grams. 50 gram of sodium chloride. 1000 ml is nothing but 1 liter, am I right, students? So 1 liter of solution contain 50 gram. I'm going to convert this mass into number of moles. How to convert mass into number of moles? Just divide this by molar mass. For sodium chloride, atomic mass of sodium is 23, chlorine is 35.5, sodium is 23, chlorine 35.5. So what's the mass?
58.5.
58.5 is the molar mass of sodium chloride. So if I divide this 50 by 58.5, I'll get this many moles. So this many moles of sodium chloride is present in the solution. Okay, 50 by 58.5. Let me use calculator. Let me use calculator. Or you tell me the rough value, close value. if you can calculate. Let me use calculator. 50 divided by 58.5. Yeah, it gives me 0.8547. So 1 liter of solution, okay, 1 liter of solution contains 0.8, what's the value? 0.8547 moles of sodium chloride. Students, in 1 liter how many moles present? That is nothing but molarity. So molarity is nothing but molarity of the solution is 0.8547 mole per liter. Students, is this clear? Any doubt in this?
Sir, can you explain the last step again?
Students? Hello?
Can you explain the last step again, sir?
Yeah. Listen, see here I just converted gram into moles, okay, mass into number of moles. How to do that? Just divide the mass by molar mass, you'll get number of moles. So you have this many moles, okay. 1 liter of solution contains this many moles. Students, this is the definition for molarity. In 1 liter, how many moles present? That is nothing but molarity. So this mole is nothing but molarity of the solution. Molarity is nothing but in 1 liter solution, how many moles present? Simple. See what I am trying to say. If I say I have a solution of m molarity, students observe this carefully. Suppose I have solution have m molarity. What is mean by that? It means 1 liter of solution contains m moles of solute. Simple. So 1 liter contain m moles of solute. Here see 1 liter contain this many moles of solute. So this is nothing but molarity. If I say some solution is m molarity, which means 1 mole of the solution contain m moles of the solute. Similarly here I have 1 liter of solution contain this many moles of solute. So that is nothing but molarity. Is it clear, student?
Yes, sir.
Right? Yeah, take down. So remember, if percentage mass by volume is given, you can calculate molarity directly without using density, because I have volume here. I have volume here also. We have volume, so density is not required here. Right? For molarity to molarity, you require density. Right? Yeah, take down. Is this clear, student? Do you have any doubt in this?
No, sir. Yes.
Okay, good. Good. Now, we'll do some more problems. At least 1 or 2 problems we'll do. Problem number 4. Calculate molality of a solution. Molality of calculate molality of 0.5 molar aqueous 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 solution of some substance, say okay, let's take sodium chloride. Calculate molality of 0.5 molar. This is molarity. Molarity is given, and now I am asking molality. Calculate molality of 0.5 molar aqueous solution of sodium chloride. What is required for this problem, students? What is required?
Density, sir.
Yes, density is required. So given density of the solution density of solution is, I'll give some rough value, say 1.2 gram per ml. Okay, 1.2 gram per ml. I'm just giving my own value. Okay, it need not be 100% correct. I have given some value, that's all. Okay, yes, how to proceed? How to proceed? You can use the direct formula actually. Direct formula also you can use, or you can use by statement manner. Okay, say for example 0.5 molarity. What's the meaning, students? 0.5 molarity, what's the meaning? 1 liter of solution contains 0.5 moles of sodium chloride. Am I right? Just now I told you. M molarity means M moles. 0.5 molarity means 1 liter of solution contains 0.5 moles of sodium chloride. Is this clear, student?
Yes, sir.
Okay, right. Now we should convert this volume into mass. So here density is given. Density is gram per ml. Okay. Here I have 1 liter. So first I'll convert this into ml. Okay. So 1000 ml. 1000 ml of solution contains 0.5 moles of sodium chloride. Right. To convert volume into mass. Okay, so you know your mass is equal to volume into density. So now we have volume, multiply this by density. Density is 1.2 gram per ml. So this ml, this per ml cancel, you will get the answer in grams. So you will get this much grams of solution contains 0.5 moles of sodium chloride. This is student, see this. This is mass of solution. Correct? 1000 into 1.2. What's the value? Student, 1000 into 1.2. 1000? 200, right? 1000 into 1.2 is 1200. So 1200 grams of solution. This is the mass of solution. Solution contains 0.5 moles of sodium chloride. Okay, we want mass of solvent. How will you get solvent? Mass of solvent, students? How will you calculate? We should subtract the mass of solute from this. That's all, right? Okay. So from 1200 we have to subtract mass of solute. I have moles of solute. I have 5.5 moles. You know, mole into molar mass will give you mass. So moles of solute. How much moles of solute we have? 0.5 mole. Into mole into molar mass. What is the molar mass of sodium chloride? Just now we discussed. We saw the value. 58.5, right? So if I multiply these two, I will get mass of solute. Mass of solution minus mass of solute will give me solvent. So this much grams of solvent contains 0.5 moles of sodium chloride. Is this clear, student? Any doubt? Any doubt? Okay. Now what I'm going to do, I'll multiply these two and I'll subtract from 1200. Okay. So I'll get the mass of solvent in grams. Let me do it. With calculator I'll do it. You just try without using calculator. It is not a difficult one, so it's very easy only. Let me do it. So 1000 1200 minus 0.5 into 58.5. Yeah, I'm getting an answer 1170.05. 1170.75 grams of solvent contains this many moles. Yeah, now tell me how to find the molality, students. How to find the molality now? Tell me. This much gram of solvent contain 0.5 moles of sodium chloride.
Moles by
What is molality? See, in 1170 gram of solvent, I have this many moles. Apo, we have to find out in 1000 gram how many solvent, how many moles present. Okay, right? That is nothing but molality. So 1170.75 gram of solvent contain 0.5 moles. Therefore, 1000 gram of solvent, 1000 gram of solvent contains how much? Very simple. Just take 0.5, divide this value by 1170.75 into 1000. Okay, I am dividing 0.5 divided by this into 1000 will give you number of moles in 1000 gram of solvent. Okay, these many moles of sodium chloride present. Okay, so what's the value of this? I'll use calculator and find it out. 0.5. Yeah. One second. Yeah, 0.5 into 1000 divided by 1170.75. I got a value 0.42707. 0.42707, right? This is the molality of the solution. So molality M equal to 0.42707. Okay, unit for molality is mole per kg. Students, is this clear? Any doubt? If you have any doubt, please tell me.
no sir.
Right. So this is how you must calculate molality if molarity is given. Okay, if molarity is given, you require density, right? First you write 0.5 molarity means what's the meaning? 0.5 means 1 liter solution contain 0.5 moles of sodium chloride. Okay, and here solution is in volume. You should convert volume into mass. How? First you convert this 1 liter into ml, and usually density is given in gram per ml. That's why we are converting liter into ml here. Okay, so 1000 ml into density is given as 1.2 here. Okay, this much grams of solution contains 0.5 moles of solute. Okay, now we have converted volume into grams. Now this is the mass of solution actually. From the mass of solution, if you subtract mass of solute, you will get mass of solvent. Okay, so this is nothing but 1200 gram. So 1200 gram of solution contain this much. From the solution mass, I will subtract the mass of solute. What is the mass of solute? Simple. Moles of solute is there, 0.5 mole. Mole into molar mass will give you mass of solute. So 0.5 into 58.5 will give you mass of solute. Subtract that value, you will get the mass of solvent. This is some mass of solvent. Some mass of solvent contain 0.5 mole. In 1000 gram of solvent, how many moles are there? That is molality. So 1000 gram of solvent contains equal to 0.5 divided by this into 1000. You will get 0.42707, and that is the molality of the solution. Is it clear, student? Any doubt in this?
No, sir.
Right? Yeah. So you must know how to calculate molality, right, and how to convert one concentration term into another concentration, right? Yeah. So these are all the things you must remember. Now what will I do? Okay, I stop here. In the next class we'll discuss the vapor pressure of solution. What is mean by vapor pressure? What is mean by Raoult's law, right? And other important concepts we'll discuss in the next class. Okay, right. I stop here. I will send you the in-text problems today.